Okay, so while organic chemistry does focus on carbon, most carbon compounds are not just hydrocarbons. Most things in our bodies and in living organisms that actually have functionality have substituents attached to those hydrocarbons, okay, or something called functional groups, or things that are different types of atoms, okay? The first set of functional groups we're going to talk about are the ones related to oxygen. Alright, so functional groups that include oxygen as a part of it. First one being alcohols. Right? So all alcohols have one hydrogen on a carbon that has been replaced with an OH substituent. Okay? So these must be drawn. The OH, and wherever it falls, has to be drawn on the skeleton. Okay? You can't leave it off. So the only way we know it's there is if you put it on there. Otherwise, we assume it's a hydrogen attached to the carbon. Okay? So as far as naming goes, again, you run into needing to change your ending. All right? We're still going to stick to straight chains. Okay? So these are going to fall somewhere on a straight chain. The prefix is still going to come from the number of carbons. Okay? You're going to change the ending from "-ane" or "-ine" or whatever it is to "-anol". Okay? And then if the alcohol is at the end of a chain bigger than 3 carbons or falls somewhere in the middle of the chain, you have to include a number indicating where the alcohol falls, the OH group. Okay, so methanol, there's only one way to draw this, and that's with your one carbon attached and one hydrogen replaced with OH. Okay, ethanol, again, you can draw the mirror image, but when you use your rule of putting it on the lowest number possible, it's always going to fall on the first carbon. Okay, it's when you get to propanol and above that you have to indicate where things fall. Okay, because butanol, this OH could fall on any of the 4 carbons. Okay, so if it falls on a middle one, we're going to call it 2-butanol. If it falls on the first one, you'd call it 1-butanol. Alright, so alcohols have an OH group, something you may want to make flashcards with, and you change the ending to "-anol. Alright? So the next functional group is a double bond, okay, a double bonded oxygen. And key thing on an end carbon. Aldehydes always form on end carbons. Okay, they don't form anywhere in the middle. So one nice thing when you're dealing with a straight chain, you don't need a number because we know it's going to be at the end. It's going to fall at 1. Okay, so with a straight chain, you're going to count the carbons in the chain, and then you are going to add the ending "-anol. Okay, so methanol, when there's 1 carbon and you have a double bonded oxygen on it, methanal. Okay, I usually enunciate the "al" at the end so that I can tell it from alcohol. Okay, so same thing with ethanal. That way you can tell it's an aldehyde and not an alcohol. And then, just so that you can kind of see the skeleton formatting here, this is pentanol because we have 1, 2, 3, 4, 5 carbons, and then you draw the double bonded oxygen on the carbon where it belongs. Okay, we are accounting for shape here. Okay, so that would be a bent bond at that carbon, but the reason why we know it's not a 6th carbon is because you have an O at the end of it. Okay? So that's aldehydes. Ketones are very similar to aldehydes, except these are a functional group that's again a double bonded oxygen, but it's on a middle carbon, meaning that the carbon has carbons attached on both sides. Okay, so sometimes you'll see this formatting R and R. R means any random carbon chain that could go in either direction. Okay, when you see R's, that does indicate that it's going to be not attached to a hydrogen, but to an actual carbon and a continuation of the organic molecule. Okay, so for ketones in a straight chain, you will need to put the number in front where that oxygen falls. Okay, so the carbon that it's on, that needs to be written at the front. And then the ending for ketones is -one. Okay, ketones end in -one, and then it's just the beginning of all of these start with an A. At least for now. So, propanone with 3 carbons, why is it that I don't need a number on this? I want you to think about it for a second. If I move that double bond to either of the other 2 carbons, am I still dealing with a ketone? Okay. If I move the double bond to this carbon, it's no longer a ketone. It's not on a central carbon, it's on an exterior carbon, which would make it an aldehyde. Okay, so propanone is the only ketone that you don't need a number with, because there's only one middle carbon, so there's only one spot to add the double bond to the oxygen and still have it be a ketone. If you have the double bonded oxygen anywhere else, it becomes an aldehyde. Okay? But just so you can see some structural skeleton diagrams again, we've got 1, 2, 3, 4, 5 carbons. Okay, I could have called that 4-pentanone, but that would have been wrong, because if I go from the other direction, it's on the second carbon. You always want to go with the smallest number. Octanone, 4-octanone, 1, 2, 3, 4, 5, 6, 7, 8. Okay, falls on the 4th carbon, and I have 8 carbons total. So, ketones. So the last functional group we're going to talk about with oxygen right now is called a carboxylic acid, or this is sometimes you'll also hear them referred to as organic acids. Okay, and this has on an end carbon. Okay, so again, this isn't going to fall somewhere in the middle, it's going to fall on an end carbon, an OH group, and a double bonded oxygen. Okay, we've been drawing these. These are those things that have that COOH at the end. Okay, so there's methanoic acid, which on the only carbon in there, you have a double bonded oxygen and a OH oxygen. Ethanoic acid. Okay, you can tell that there are 2 carbons here because there's one at this end of the line, and there's also one at this vertice. Okay, and the one at the vertice has the double bonded oxygen and single bonded OH. Okay. Heptanoic acid, based on hept, should have 7 carbons. So we've got 1, 2, 3, 4, 5, 6, 7. Okay, and then the double bonded O and the OH. So as far as naming these goes, again, with straight chains you won't need any numbering. And you're going to count your carbons to get your prefix, and then add anoic acid. Okay, so methanoic acid, heptanoic acid, hexanoic acid. So these shouldn't be too bad. There is a associated online quiz with this one to get some practice and make sure that things are sinking in. Things you want to be able to do is identify your functional groups. Okay, if I give you, sometimes the question might just be what functional groups are present, or it may be naming or drawing. Okay, several of these only fall at the ends. Okay, the carboxylic acids and the aldehydes. Ketones are double bond, they're going to fall somewhere in the middle for sure. And then the only one that can kind of do anything are the alcohols. Those can fall at the end or in the middle. So just pay attention to numbering for the ones that have to fall in specific spots.